there! So, today we're going to resolve some partial fractions. Now, resolving into partial fractions can be particularly useful in calculus, but essentially the goal here is going to be to take one fraction and split it into multiple fractions. And by doing so, the denominators will be smaller. Say, for example, like if we wanted to resolve this function f of x into partial fractions. Well, first thing we'd want to notice is that the denominator is already factored. Now it has a multiple factor, x plus 2 is repeated, so that means we're going to have to remind ourselves of a special strategy. And that is that when we have partial fractions with a repeated factor, such as this x plus 2 is repeated, the way we handle it is by splitting those partial fractions where you have one denominator is the overall power you have, in this case a square. And then you add another partial fraction where you have one less of that power, in this case x plus 2, and you would keep going. Like let's say if we did have x plus 2 cubed, well then we would have done 1 over x plus 2 cubed, then plus another one with x plus 2 squared, then plus another one with x plus 2, and so on. Alright, so now since both of those factors though, they're the same thing, they're x plus 2 and they're linear, we let the numerator be some mystery coefficient. It is going to be a constant though because they have to be lesser degrees than the denominator. We'll see an example next where this is not the case, where it won't just be an a plus b, so more on that later. But we do need to make sure they're two different letters. We usually represent them as capital letters because that way we distinguish them. They're easier on the eyes to be able to be seen as something different than just x. But they could be different numbers, so don't just use a and a. Alright, now since we maybe don't like working with fractions if we don't have to, I mean if you do, that's awesome, get a common denominator. But if you don't, let's just clear out the fractions altogether by multiplying through by that LCD of x plus 2 squared. Alright, so that's what we're going to do here. Now, when we distribute it into the first, we just get 4x plus 2, then we distribute it to each of those partial fractions, leaving that a and that b. Now, I didn't distribute in that b because I'm going to use strategic values for this first example. Now, strategic values, you can pick anything you want, but can you see why x equals negative 2 would be a good idea? Well, if not, we're about to see why. Technically, you could pick any number if you wanted, but I particularly like negative 2 for this problem. And that's because when I plug in negative 2, I am getting 0 there for that b. And that will allow me to solve for a right away, and it will end up being negative 6. Now, I don't see another, maybe at first, super duper strategic values, but you know what value is always strategic if there's not one that's obvious? 0. Because it's really easy to work with. So let's see what happens when I put in 0. Well, on the left, I'll end up just getting a 2. And on the right, at first, maybe it seems like not that useful. I still have the a and b. But don't forget, we have a already. So I'll be able to replace that a with negative 6, and that will allow me to ultimately solve for b. Now that I have a and b, I actually have my partial fraction, my final answer, where I'll replace a with negative 6, b with 4, and then what I have is I have my initial fraction split into two smaller partial fractions, which would be easier to integrate if, again, that were something I were doing next year in calculus. So we've met our objective. We have now gotten our one fraction into the partial fractions that would be desirable for us to manipulate in our future. Alright, so now let's look at another example. Let's say this time, though, we wanted to resolve this expression. So now we don't really have an equation so much as an expression here since there's no equal sign. So I see that denominator. No, it's not factored for me. So that's going to be my first step here. Last one it was factored. This time, though, I'm going to factor myself. Here it's factorable by grouping would be one method, probably the easiest. And then I can see those two factors. Now those factors are going to be what I use to split into my partial fractions, also known as resolving. So let me resolve this into partial fractions here. Now I've got two denominators for those two factors, x squared plus 1 and x minus 1. But here's a conundrum. I have now factored fully across the rationals, meaning that I don't introduce any imaginary numbers. If you remember from earlier in the year, that could have been a problem, but we don't do that when we're resolving to partial fractions. We keep everything nice and rational. So, back to the problem at hand. That factor x squared plus 1, he's not linear, he's quadratic. So that means that my numerator in that partial fraction is going to need to be represented by ax plus b. I only know it has to be 1 degree less. It does not have to be a constant. So since it's again quadratic, I'm just assuming it's linear. That's a safe assumption. Assuming it's a constant would not be safe. If it had been a constant, maybe I'd solve and get a is 0, but it's going to turn out not to be. Okay, so now continuing on our merry way, we're going to multiply through by the LCD to destroy the fractions, and let's see what happens. So I'm going to distribute it in. I'll get this to that numerator, x squared minus 3x minus 2. Then I'm not going to FOIL at first, but what I do notice is this one might be a little messier. While I might see a good strategic value of 1, the others don't look so friendly. The other strategic values would be I and negative I, and I don't really feel like using those, the imaginary numbers. They're not going to be friendly. So let's see the other method of resolving fractions that we learned earlier, and that would be using your coefficients. So if you're going to use your coefficient method, then what you're going to do is you're going to FOIL everything out, you're going to distribute, and then that's going to help us because it's an equation. Both sides have to be balanced. So that means that the squares have to have the same amount on each side. So if there's an x squared on the left, there would have to be just one x squared overall on the right, meaning that a plus c would have to be 1. We could do the same thing with the linear components. Negative 3x has to balance with bx minus a, so that means that b minus a has to equal negative 3. And we could do one last balanced portion, being the constants. Negative 2 would have to balance with that negative b plus c. Now at first this seems like a big old mess, but he's a 3 by 3 system with 3 variables. So we're going to solve like we learned in Algebra 2. I'll pick a variable to get by itself, say for example like c. I just happen to have it as my last value I got, so that's why I picked with that side. It wouldn't matter where you started. And now I'm going to replace the c that I have in my purple section, favorite color, and we're going to replace it, and that will give us a new expression. Possibly at first not seeming that helpful, but if you remember in Algebra 2, your goal here was to get now a 2-variable equation. Once it's a 2-variable equation system, for example now our new purple with our blue, that would be a 2-variable system, we'll be able to solve. So that's what I'm going to do. I'm going to isolate b, and then that will allow me to plug into my blue equation and then solve finally for a, which is 3. The rest will fall into place much quicker now. I'll replace a with 3, solving for b in the purple, and then replace b with this newfound 0 and solve in the yellow for c. Now I have all 3, and I can get my final answer. I'll replace a with the found value of 3. Notice b is 0, so there didn't even need to be a constant section there. I need to put it there, don't get me wrong, you have to put it there, but it just turned out it wasn't necessary for this particular final answer. Could be in the future though for others. And then I got my c, which is negative 2, which by the way, could I put it as plus negative 2? Sure, but I changed my mind. I decided since he was that negative 2, I changed that addition to subtraction. Alright, well hopefully that helps you refresh your memory on partial fractions, and enjoy the rest of your day.